The Boeing Dreamliner that crashed on June 12, 2025 is at the center of a growing mystery. According to early investigation reports, the fuel control switches in the cockpit inexplicably shifted from the run to the cutoff position, a change that immediately shuts down the aircraft's engines. Cockpit voice recordings captured the stunned voices of the two pilots as they tried to make sense of what was happening. In disbelief, one asked the other, "Why did you cut off?" A question that made it clear neither of them had intentionally shut down the engines, but the reports says otherwise. Air India flight from Ahmedabad to London was carrying 242 people on board, 230 passengers and 12 crew members. Tragically, everyone on the flight lost their lives except for one survivor. In a remarkable twist, reports suggest that a man seated in seat 11A near an emergency exit somehow managed to escape or ejected just before the crash. More details all in the video ahead. 3 seconds to disaster. The story behind Air India flight tragic dual-engine failure. On what began as an ordinary day, Air India flight prepared for takeoff from Ahmedabad Airport. The skies were clear, the aircraft, well-maintained and staffed by experienced pilots, was ready for its scheduled journey. Everything appeared routine. But within seconds of liftoff, something unthinkable happened. A smooth takeoff turns sudden. At 8:08 GMT, the aircraft began its takeoff roll down the runway, accelerating steadily. As the nose lifted and the wheels left the ground, the plane climbed with expected power. By the third second after liftoff, it had reached a speed of around 180 knots, typical and well within safe parameters. But right at that moment, just 3 seconds into the flight, the normalcy ended. This is where a critical, sudden action happened. In the cockpit, both pilots were carrying out post-takeoff procedures when, inexplicably, a critical error occurred. The fuel control switches for Engine 1 and Engine 2, the controls that allow fuel to flow to the engines, were moved from run to cutoff almost simultaneously. Within about 1 second, both switches had been thrown, one after the other. This action abruptly severed the fuel supply to both engines. It wasn't a mechanical fault. It wasn't turbulence. It wasn't a system glitch. Something or someone had physically moved both switches. This is according to the report. Basically, they blame the pilots, but I do believe it might be some technical error. Why did you cut off? In those next few moments, the cockpit voice recorder captured a tense and confused exchange between the pilots. "Why did you cut off?" one asked, alarm in his voice. "I didn't," came the immediate reply. This short but chilling dialogue reveals a moment of sheer disbelief. Neither pilot appeared to understand what had just occurred. Neither had knowingly taken the action that caused both engines to shut down in mid-air, just seconds into the flight. The engines wind down. With no fuel flowing, the aircraft's engines began winding down rapidly. The engine speeds, monitored as N1 and N2, dropped sharply. The aircraft, now without thrust, was essentially gliding. But it wasn't designed to glide, especially not this soon after takeoff, and especially not at low altitude. Almost immediately, the aircraft's emergency backup system kicked in. The ram air turbine, a small wind-powered device used to generate emergency hydraulic and electrical power, deployed automatically. This helped maintain minimal control and instrumentation, but couldn't restart the engines or stop the descent. Here comes the desperate attempt to restart. Roughly 5 to 10 seconds after the engines had shut down, the pilots attempted to recover. They moved the fuel control switches back to run, trying to restore power. There was a flicker of hope. Engine 1 began showing early signs of recovery, but Engine 2 remained lifeless. The aircraft, however, was already in a steep descent. There was not enough altitude, not enough time. Despite frantic efforts to relight the engines and regain control, the aircraft continued to lose altitude rapidly. Seconds later, it impacted the ground. In the days that followed, investigators from the Air Accidents Investigation Branch put this report out. There was no evidence of tampering, no technical faults, no fuel issues. The switches that shut off both engines were found to be mechanically sound. They cannot move on their own. They require deliberate manual force to operate. This meant one thing. Someone in the cockpit had physically moved both switches, but the pilots themselves seemed unaware of having done so. The investigation to date has not uncovered how or why this happened, only that it did. Here is the key moment. The entire tragedy hinged on a single mystifying moment: the near simultaneous manual movement of both fuel control switches from run to cut off. There was a split-second action that set in motion an irreversible chain of events. There was no second chance, no way to gain back altitude, no miracle recovery. At around 1:44 p.m., the aircraft crashed into Meghani Nagar, a densely populated neighborhood just outside the airport perimeter. The plane struck a hostel building on the campus of BJ Medical College, where students were inside. After the crash, several scenarios were analyzed by aviation experts, but the official investigation concluded that the fuel cutoff was one of the major driving factors. But we should also take a look at the different scenarios to help us understand better. One particularly remarkable detail has emerged. The sole survivor of the Air India Flight AI117 crash reportedly heard a loud noise just 30 seconds after takeoff. We'll come back to that, but for now, let's take a look at how he managed to survive. The passenger, Vishwas, was seated in 11A, a seat located in the first row of the economy cabin, close to an emergency exit on the Boeing 787 Dreamliner. As the aircraft began to lose altitude rapidly and headed toward a residential area, it was initially unclear whether it had struck a building. However, according to reports, Vishwas reportedly managed to push open the damaged emergency door and walk out of the wreckage. Contrary to earlier reports suggesting he had jumped, he actually walked away from the crash site. This was possible because the plane had only climbed to about 625 feet before losing control, meaning it was flying at a relatively low altitude. Such an escape may have been physically possible under these circumstances, though it remains incredibly dangerous and nearly unimaginable. Coming back to the survivor, he reported hearing a loud bang shortly after takeoff. This sound might have been an engine failure. What's puzzling is that no smoke was visible in any of the video footage taken at the time. That absence of visible smoke raises the possibility that both engines may have lost thrust simultaneously. Such a scenario could result from a mechanical failure within the engines or a problem with the aircraft's fuel system. Either way, losing thrust from both engines right after takeoff would make it extremely difficult, if not impossible, for the aircraft to gain altitude or maintain controlled flight. There's also speculation about a potential mechanical failure involving the aircraft's control surfaces, specifically the flaps, which play a crucial role in generating lift during takeoff. Any malfunction here could have resulted in an immediate and dangerous drop in altitude. On the Boeing 787 Dreamliner, including those operated by Air India, standard procedure during takeoff involves extending the flaps to a specific setting, typically flaps 5 or higher. The exact setting depends on the aircraft's weight, the runway length, and other performance-related factors. Once the aircraft has safely accelerated and gained altitude, the flaps are gradually retracted. This process is essential for transitioning the aircraft into climb mode. However, in the case of the Air India crash in Ahmedabad, it appears the flaps were either fully retracted or not extended at all during takeoff, an abnormal and highly dangerous condition. Taking off with flaps retracted or retracting them too soon drastically reduces lift at low speeds and altitudes. This compromises the aircraft's ability to climb and significantly increases the risk of a stall or complete loss of control. We also make original engineering content, so please subscribe and hit the notification bell for more videos.